Hello, welcome to Chemistry 101 tutorials. If it's your first time joining us, please go down there and hit that red subscribe button. Okay, today's question is, how can you prepare 500 milliliter of 0.5 molar, that's the concentration of HCl solution, from a stock solution of 37% HCl with a density of 1.2 gram per milliliter? Okay, so the first thing first here in this case, what you have to do is to first calculate the concentration of the stock solution. Okay, and we all know that concentration denoted by C is equals to moles of the solute divided by the volume of the solvent, but in this case should be in liters. Okay, all right, so moles per liter, that's the concentration. This is equals to or is mostly denoted by big letter M. Okay, like in this case here, this is the big letter M, even though it doesn't really look like, but yeah, sure, it's the big letter M standing for concentration. Okay, so first thing first, we have to calculate the concentration of the stock solution. So we will do this calculation from the density, since we are given the density. So the density of stock solution is 1.2 gram per milliliter. Okay, so that means we have to make sure that this unit goes to moles per liter. Okay, that's really easy to do, and I'm going to show you this in this video. So in this case, we will multiply this with the molar mass of HCl. So in this case, since I want my moles to be on the numerator, so I will have 1 mole. Okay, so multiply here with the molar mass, so 36.5 gram. So this is the molar mass here. In this case, this is the molar mass of HCl. Okay, so grams and grams will cancel out in this case. So your answer will be now in mole per milliliter, but the concentration is moles per liter. Okay, so in this case we have to convert the milliliter to liters. In this case we will multiply with the conversion factor, so 100 ml over 1 liter. Okay, so you know that 1 liter is equals to 1000, not 100, 1000 ml. Okay, so this is the conversion factor. So in this case the ml will also cancel, and your answer will be in grams. It will be in mole per liter. But here in this case, in this case, you are told that the concentration of the acid is 37%. All right, so you have to keep that in mind. So here we will come and multiply by 37%. So 37% is the same as 37 divided by 100. Okay, so then this will be equals to this will be equals to 12.16 moles per liter, denoted with big letter L. Okay, so this is the concentration of your stock solution. Okay, this is for the stock. All right, so we know the concentration of the stock solution, and now let's prepare our 0.5 molar acid solution. Okay, so in this case now we are going to use the dilution equation. C1V1 is equals to C2V2. Okay, so the C1 here is the concentration of the stock. All right, so stock, and also the V1 is also for the stock. Okay, all right, so this one is the one that you want to prepare, which is 0.5 molar, and the volume you are already given, which is 500 milliliter. Okay, so in this case, because we are working with molar, which is moles per liter, so this one will be converted to liters, which will be 0.5 liters. Okay, so we are going to use this equation, and most importantly, What we are going to calculate here is the volume of the stock solution. The volume of the stock solution that we will use to prepare this concentration, okay, in that given volume. All right, so let's do it stepwise. Okay. All right, so in this case, we'll calculate our V1. V1 will be equals to, so in this case, we will have 0.5 molar multiplied by 0.5, I already converted it, divided by 12.16 molar, okay, and our V1 will be equals to 0.20, 0.0, okay, says 0.020 liter, which can also be converted to milliliters. So multiplied by 1000, you will get 20 ml, okay, in this case. So didn't have to put this comma here. Okay, so this will be 20 ml. All right, so and now to prepare this solution, we will then have to go to our, let's say, it's our beaker. All right, so this is our beaker. Let's say this is the 500 ml. This is the final volume here. Let's say I will put it like that. Okay, so first you will fill this beaker, because now the concentration of the stock that you have to put is 20 ml. So, and the volume that you have to, the final volume is 500. Okay, so first you will fill this with water, maybe until this mark, let's say 450 mark. Okay, and then after, so this will be water, and then after that you will add, so you will continue to add 20 ml of stock solution. Okay, so you will add 20 ml of stock solution, and your volume, let's say, will be at 470 here, and then you will add another water, another remaining water until the mark, until the 500 mark. That means you will add another 30 ml of distilled water. Okay, not just any water, but distilled water. Okay, so by so doing, you will have prepared, in this case, your 0.5 molar, and the final volume of that solution will be 500 ml. Okay, so what is often asked is that is it acid to water or water to acid? Okay, so sometimes they ask you this question, and the answer here I already gave it. Okay, so every time you have to add the acid to water, okay, not water to acid. This is a no-go area. Why? Because if you add water in a concentrated acid, the reaction is very exothermic, and what will happen is that the acid will start jumping up, and it might burn your face, or it can burn anyone who is close by. Potentially it will first attack you. Okay, so first, in order to avoid this, you have to add your acid to water. Okay, this, never try it, please, never try it. If you care about your face, then never really try this one, never at all. So always acid to water. All right, okay, I hope you enjoyed this video, and if you enjoyed this video, please give it a thumbs up, and if you haven't subscribed, please hit that subscribe button. I'm going to also upload another video whereby I will call it part 2 video, whereby I will explain how to prepare solution from solid materials. Okay, let's say, yeah, from sodium hydroxide, maybe anything that is in solid form. Okay, all right, okay, bye bye.